Hey guys, welcome to assignment 1-2. So let's make sure we know everything that should be scanned in a single document to get all our points for this assignment this week. All right, first you should have taken notes in example 1 and example 2. If you missed class, we really just copied these examples from the book. You can also get them off of Canvas in each step. So make sure you take a picture of example 1, 2, 3, and 4. We're actually going to use some of those to do our assignment today. So the other part of this assignment was question 10, 12, and 27, 28. So let's do it. On question number 10, it says, how would you use a compass to determine if two segments are the same length, right? So I didn't bring home a compass. You know, I don't really use one here at my house. Maybe a lot of you might be surprised about that. So if I'm looking here at these two segments, they actually, I'm going to actually do the opposite. I'm going to verify if they're the same, if they're different, because these seem very obviously different. So you can use a paper clip as a compass, and I'm just using this example number 5 to kind of show what I'm talking about. So right here, if I make an arc from A, it's very obvious that this line segment AB is shorter than the distance between the length of the inside of this. Now, if I do the same thing over here, CD, ooh, interesting. This one's a little bit longer. So see how I've kind of used the compass to verify these are different. Now, how could I use a compass to verify that they're the same? Well, I think, right, you could probably hypothesize here that if AB matched the length of this compass, if AB was in fact exactly the length of that compass, and CD was also exactly the length of how open I had the compass, that the arc would be the same. So in a way, I can use, even though it's not a ruler, I can use a compass in this fashion to verify that two segments are the same length. Okay, so let's see. I gotta go ahead and write that down. I can make an arc from one end point, right? Using a compass. Then repeat. On the other line segment. And if the arc is the same, the two segments are the same length. Now, none of this really seems to, none of that makes as much sense than my actual picture. So if you wrote something down and you like what you wrote down, don't write down what I wrote down. But if you like certain things about what I wrote, you might want to jot down some stuff. So maybe you didn't use the word endpoint or compass, or maybe you didn't compare the two segments. So if you want to just add a line or off to the side, add a comment. Also, if you didn't add a picture and you watched the video and you like the picture that I drew, jot that off to the side. Again, the video is not to just copy off of, right? That's not really the process. The process is really work through the questions on your own, do your best, watch the video, and then try to use a different color pen or pencil. Maybe do your homework in pencil, and then with a pen after watching the video, you annotate it, which means almost like in an English class, you go in and you add and subtract different things that you think would make it better. Okay, so using that as a guide, hopefully that helped you understand question number 10. Now looking at question number 12, it says, make sense and persevere. In the figure shown, suppose that the measurement of ABC is in. So let's highlight that. ABC is in. So that's my whole thing. Now I'd like to give you a technique. And that's something else you can do is you can kind of add, maybe you like how you answered number 12, but watching the video, you're like, ooh, I like that technique. So the technique I think that might be useful here is use made up numbers. Even if they're wrong, but approximately right, to help the problem make sense. Okay. So to kind of continue our thoughts here, I'm going to use my eyeball. And again, feel free to go to the dollar store and get a protractor. And even though this picture might not be exact or it might just be a guide, I can kind of make up numbers here. So I see that this angle is a little bit smaller than 90 degree. That's a 90-degree angle, the corner of my paper. So I'm going to assume, I'm going to say if the measure of angle, I got to put the little m there, if the measure of angle ABC is 80, then we're supposed to call that in. Okay, so step one is done. Then they're saying, well, what if ABD, so that's this angle, got another color, ABD. What if ABD was 2 times DBC? Okay, so 2 times DBC. 2 times DBC. Two times DBC. Wow, so my picture is actually not to scale. So I'm actually gonna, and this is another tip, I'm gonna redraw picture to make it more true. Okay. So I've got a big angle. Maybe it's bigger than that, bigger than 90. And it says that the yellow or pink angle is 2 times the purple angle. Okay, so this would actually be purple angle. So the pink angle is twice as big. So notice what I've done there is when I redrew it, now this purple angle right here is looking about twice as big. So if this was angle 1, this is angle 1, and this is angle 1. The pink one is twice as big. All right. And this is still A, B, D, and this is still D, B, C. Now it says the angle bisector of DBC, the angle bisector is BE. So this line cutting right in here, cut it in half. So if this is angle 2, angle 2 is actually half as big because angle bisector means cut in half. Okay, so let's use our strategy. Let's say this whole really big number looks like the biggest angle is 120, right? And then this orange one is angle 1, 2, 3. So I actually picked a number that was easy to divide by 3. So if I divided it by 3, it'd be 40. So each angle 1 that I made is equal to 40 degrees. So this would be 40, this would be 40, and this whole angle would be 40. So as I look at this, these would still be a true statement. ABD would take 40 and 40 make 80. And we say, is 80 2 times 40? The purple angle, DBC. Yeah, 80 is 2 times 40. Then they took the purple angle and cut that in half. So my angle 2 would be half of 40, which would be 20. Now they're asking, what is EBC? EBC. So notice that's my little angle, angle 2. When I compare my whole angle to my little angle, it looks like it's a sixth of that. So if we started out saying that the whole angle is in, so angle ABC is in, I ended up having to cut in thirds, 1, 2, 3, because this one was twice as big. And then I cut that same angle, so that's angle 1. And then I ended up having to cut that same angle in half again. So n divided by 3, cutting it in half one more time gives me n over 6. So that's what they're looking for here in example 12. Thanks for joining me, guys. Check out the next video for the last 2 questions in the homework this week.